In this recording, we're going to go over how to use Desmos to run a regression. So I have the data from the Dizzy Lizzy amusement park problem from earlier this week. And the top row here is the hours, and then the bottom was the number of people that were standing in line. So I'm going to turn this into a table on Desmos. So I already have my Desmos open. I hit the plus and I go down to table. Now, I'm going to use this top row as my X values, and then I'm going to use the bottom one as my Ys. Sometimes if it's, a vertical chart, you're going to use just the X is usually going to be on the left and the Y is going to be on the right. So I'm just going to type all this in. So the top row is 0, 1, 2. You can see it thinks that it's just, automatically filling out for me, but we don't have a 3 on our chart, so I actually have to start overriding that 7, 8, 10, and 12. And then I go over to Y1. I'm just going to type the Y column in. 75, 225, 345, 355, 310, 180, and 45. Now to get the actual graph, since I'm done with the chart, I'm actually going to make this bigger. But to get the actual graph to pop up, because you can see I only see a point here, but I don't see a lot of data. So I want to hit this button here. Looks like a magnifying glass with a plus, and it says zoom fit when I hover over it. You click on it, you get all of the points popping up. So this is the full data set. Now to run the regression, you just go to the next line. And I'm going to start with Y1 because it's pulling the information from this column that says Y1. And whenever I write X, I'm going to write X1 because I'm going to pull the information from this first column. And this is how the calculator knows where to get the information from. So Y1, and then we're just going to go in alphabetical order. I could try a linear regression. That doesn't look right. So you can see that its correlation coefficient is very low. I'm going to go and try Y1, and I'm going to try a quadratic. A x1 to the second plus bx1 plus c. And you can see the points fit fairly well. And the correlation coefficient here is 0.9678. That's pretty close to 1. But I'm going to try a cubic regression just to see if I can get a little bit closer. Ax1 to the third plus bx1 to the second plus cx1 plus d. And if you look, the correlation coefficient for this one is actually even closer to 1, 0.9826. So this is the equation that I'm going to go with. So I can get rid of the quadratic, and this cubic function is going to be the one that I use for modeling this situation. If you were to write the equation, you just write y equals, and now you're going to take these values that are listed as the parameters, you're going to put them in for A, B, C, and D. I'm going to go 2 decimal places, 0.37 x to the third plus negative 16.61 x squared. You could have just written minus 16.61, but if you're going to write the negative, make sure it's plus a negative. Plus 150.30 x plus negative 21 or minus 21.25. And you can see that this new graph that's in blue fits almost perfectly. It sort of, makes a little bit of a difference towards the end. They sort of diverge a little bit. But remember, a regression is a model that's not perfect, but this is the regression for this set of data.